Alright, on lesson 8 and lesson 9, we're going to combine them really quickly. So what we're going to do is we're going to do the decimal expansion of this. So that just means we're going to do long division. See how that says that? So 26 divided by 4. Okay, 4 goes into 26 6 times. 6 times 4 is 24. We subtract and we get 2. We add a decimal, put a 0, bring it down. 4 goes into 25 times. 5 times 4 is 20. We subtract and we're done. So 26 over 4 is 6.5. And that is finite. It ends. We would do the same thing here. 142 divided by 2. 2 goes into 14 7 times. 7 times 2 is 14. 0, we bring down the 2. 2. 2 goes into 2 once. 1 times 2 is 2. So 142 over 2 equals 71. There's another way we can do it, but we're not going to worry about this. Okay, and this would be finite as well. So that would be 8, and then we're going to move on over to lesson 9. We're going to do the opening exercise here together. Okay. Compute the decimal expansion of 5 6 and 7 ninths. So 5 6 will be 5 divided by 6. That doesn't work. 6 cannot go into 5. So we put a decimal of 0. 6 goes into 50. 8. 6 times 8 is 48. 2 0. 6 goes into 18 3 times, or 23 times. 6 times is 18. We get a 2. So if I did this again, we'd go back to this. So 5 6 equals 0. Because it's the same thing, the 3 repeats, 0.83 repeated. Okay. Then if we did 7 ninths, 7 divided by 9, this doesn't work. 9 goes into 7 times. 7 times 9 is 63. We subtract and we get 7. So we're doing the same thing, so that's going to repeat. So 7 over 9 is 0.7 repeated. Okay. B says, what is 5 6 plus 7 ninths as a fraction? What is the decimal expansion of that fraction? So we're going to have to add these together first. So I'm going to do it over here, and then I'll do the decimal expansion. We'll do it here. 5 over 6 plus 7 over 9. We want the denominator to be the same so we can add fractions. So the lowest number that both of these will go into evenly is 18. So over 18 for both of them. So I multiply 6 by 3 to get 18. So I'm going to have to multiply the top by 3 to get 18. So 5 times 3 is 15. Over here, I multiply by 2 to get 18, and I multiply by 2 to get 14 here. So when I add them together, 15 plus 14 is 19 over 18. No, 29 over 18. I can't add today. And then we want the decimal expansion of that. So then we would take 29 divided by 18. It goes into there once. 1, so we subtract. 1, 1, we add a 0, we bring it down. 18 goes into 110 6 times. 6 times 8 is 48. 6, 7, 8, 9, 10. We subtract and we get 2. Add a 0, bring it down. 1. 1 times 18 is 18. We subtract and get a 2. 0, bring it down because these are the same. The 1 will repeat. So 29 over 18 is 1.61 repeated. What is 5/6 times 7/9 as a fraction? So we would multiply this across. So 5/6 times 7/9, multiply straight across. 5 times 7 is 35. 6 times 9 is 54. And then this says according to the calculator, so this is where you would use a calculator. So 35 divided by 54. If we did it with a calculator, we would see that this was 0.648, 148, 148, ... This rounds it, okay? 6418 or 6481, 481. This will be 481, but the calculator rounds it, okay? So this would go on forever. D, if you were given just the decimal expansion of 5/6 and 7/9 without knowing which fractions produce them, do you think you could easily add the two decimals to find the decimal expansion of the sum? Could you easily multiply the two decimals and find the decimal expansion of their products? Okay. You could not easily figure out the fractions. Because you could not easily add the decimals because they are infinite. They go on forever. Okay? And the same thing for multiplying. You could not easily multiply the decimals because they are infinite.